Hello there. Welcome to Calculus. In these sets of videos, we're going to go ahead and discuss calculus and its various ideas, applications, and this video is the first of the course. This video will specifically focus on limits, and we will start looking at this foundational idea of calculus in the form of graphs. So we'll go ahead and jump right in. The foundation of all of calculus is the concept of limits, and this idea will be tied into everything that we do in this course, including the main ideas of derivatives, integrals, and of course series if you're taking Calc BC. So what we need to do to understand limits is first of all just talk about these ideas. What is a limit? How is a limit similar and different than a point on a graph? How do we write limit statements? And how do we read limit statements? And those last two specifically tied to notation, which is extremely important on the AP Calculus exam. So let's go ahead and dive in and answer the first question here. It says, what is a limit? Well, a limit specifically is a y value. Underline that or highlight that. It is the y value. Your answer should always be a y value. And we get this y value because the graph or the function gets closer and closer to, but it may not actually get to it as the x values get closer and closer to a specific point from both sides. And go ahead and underline that both sides part. It has to come to a specific y value from the left and from the right, and we'll look at those specific cases here in a moment. So let's go ahead and look at some examples. The first example here, we have a graph of f of x, and the example says the limit of f of x as x approaches 3 is equal to 2. So of my function, as I am approaching 3 from the right, I'm going to this point, and as I come from the left, I approach that point, and notice that the y value is 2. So that would be the answer. So the limit as the function gets closer and closer from the left and from the right, it is 2. Let's look at the second example. Here we have g of x. Now again, the function as x is approaching 3, this time I'm coming from the left, it's approaching 2, and the limit as it is approaching the value of 3 from the right, it is also 2. So our answer is 2. All right, and then example number 3. Here we have h of x, and notice for h of x, it's just a linear function, and the limit of h of x as x approaches 3 is also 2. So here I have nothing funny going on, as in the last examples. We're just going along a function, a normal, perfectly normal function, and there from the left and from the right, they're both approaching 2. Notice all of these have a limit of 2, but they're kind of different in each of these cases. Notice in the first example, we're coming to a point right here at 3, and I also have a hole there. There's a discontinuity. So no problem. The limit from the left and the limit from the right are equal to each other, so therefore the limit is 2. Same with example number 2. Again, I have a hole here. Here's a discontinuity. It's smooth at that point. That's fine. And in this case, I have a function value. The actual function value at 3 is 4. It's okay. The limit still at 3 is 2. Okay, it's about the whole function, not specifically at that value. So I've kind of been reading these examples and talking about them, but here we specifically want to talk about how you pronunciate and how you read limit notation. So here we go. Write this down or underline this, maybe color code, highlight if you have those supplies available to you. So here, okay, we read this as the limit of f of x, just like a function, how you say of, right? The limit of what? The limit of f of x. Okay, then we describe the x values as x approaches 3. So as x approaches 3, And then we say it is 2. It is 2, or it's equal to 2. So that's how you would go ahead and read a limit, okay? If you need to pause it and go ahead and read some of these other examples and see if you got it, go ahead and feel free to do that. So let's go ahead and look at some examples here, and let's go ahead and try to accomplish these. So example number 1, use the graph of g of x above to answer the following. Okay, A, the limit of g of x, well, here's g of x, I have this image given to me, as x approaches 4, okay, so I'm interested in this x value, is equal to, well, from the left, I'm coming here, oh, there's a hole. Well, from the right, hey, they're both approaching the same location. Okay, so, and the y value for that is 1. So our answer would be 1. All right, example number 2, or B, I guess I should say. Number B, the limit as x approaches 1 of g of x is, sorry, the limit of g of x as x approaches 1. So as I go from the left, well, it is 1, and from the right, it is 4. Are they meeting at the same location? No, they're like this. There's what we call a jump discontinuity there, right? It's like that point jumped way up there. So we would say that this does not exist. And you know, this bugs me. I'm going to cross off these equal signs, and I'm going to write D and E. You don't ever want to write equals D and E. So just does not exist. Does not exist. Does not exist. Exist. I hope I spelled exist right. I think it is. I think it's right. All right, the next one. We'll go ahead and look at 4. G of 4. Well, this is just a function value. So if I go to my graph and I say, okay, here's 4. What is the y value at 4? Well, here's my closed dot. This is what this actual value is, okay? And that's at 2. So different than the limit. Different than the limit, okay? And we'll talk about what those implications are later on in this unit. All right, D, the limit of g of x as x approaches 2. All right, well here, again, nothing funny going on. This is just a regular old point. It's possible to have limits at these points, and we actually like them because they're nice and easy. So the limit of g of x as x approaches 2, that is just 1. Okay? All right, so we kind of have been talking about limits from the left, limits from the right, and now we're going to go ahead and talk about one-sided limits. The limit of g of x as x approaches 1, in this previous case, it does not exist because we are approaching 2 different y values from each side of the graph. This brings up the idea of one-sided limits. And you are familiar with this notation if you have taken accelerated math with me, myself, or Ms. Page. And we've used this notation before, and you'll notice it's slightly different. You'll notice the subscript here as we talk about what x values the limit is approaching. So here we say the limit of g of x as x approaches 1 from the left. From the left. Okay, and again, that's what that negative sign means. So from the left, as I approach 1, my y value is 1. So the answer would be 1. Second example, from the right. So the limit of g of x, and then here, as x approaches 1 from the right. And this is again 1 from the right. Just translating that mathematic notation into plain old English. So the function from the right, the limit of g of x as x approaches 1 from the right, it is going to 4. Okay? And that's the idea of one-sided limits. Now, be careful. Here's a note. When you have a limit from the left, somehow some people get that confused, like you're going left. It's like, no, you're coming from the left side. You're coming from the left side, right? This is not Beyonce's song, to the left, to the left. No, you're coming from the left, from the left. You just picked your stuff up. Okay? All right. Example number 2. Example number 2. We're going to go ahead and go through these. The limit of h of x as x approaches 3. All right, from the left going to 1, from the right going to 1. So the limit it is 1. B, the limit as x approaches 2 of h of x. Well, from the left it's going to 2, and from the right it's going to 0. Remember, it's a y value. So our answer here, I'm going to cross off that equal sign. I don't like that. D and E does not exist. The limit does not exist. C, what is the limit of h of x as x approaches 2 from the right? Coming from the right side. So that is this section right here, and it's going to 0. Okay, D, trying to throw us off here. What is h of 1? So what is the function value, right? This is an x value being dropped into h of x, and the output is right here, and that's just going to be 1. Don't care about the limit. It's just the function. All right, E, what is the limit of h of x as x approaches negative 1 from the left? Okay, so as I go from the left, I'm going up to 2. Now they want the limit of h of x as x approaches negative 1 from the right. Well, as I go from the right, we're going down to negative 1. Okay, and then now it says, well, what's the limit as x approaches negative 1? Of h of x, sorry, limit of the h of x as x approaches negative 1. Well, they're not equal, so this limit does not exist. D and E. D and E. Okay, and lastly, what is h of negative 1? So what's the function value? Well, if I look at negative 1, notice I don't have a closed point, a dark point like I do at positive 1, right? So here, this function value is what we call undefined. It's not defined on this graph, undefined. Okay, only limits cannot exist, right? So only a limit does not exist. Only a limit does not exist. Say it with me. Only a limit does not exist. All right. Example number 3. Write a limit statement for each of the criteria below. So here we're going to practice writing our limit notation, and this is extremely, extremely important. So a limit that exists. All right, let's look for a limit that exists. Okay, how about right here at 4? That limit exists, right? The limit from the left and the limit from the right do exist. So I'm going to say, okay, the limit, L-I-M, lim. Now what's the function? The limit of f of x. That's my function right here, f of x. Okay, the limit of f of x. And then what's the x value? 4. So x arrow 4. X is approaching 4, and it's small. X approaching 4 is small, and it's right underneath the limit. Okay, so the limit of f of x is x approaches 4, and then let's go ahead and give an answer. Well, that y value would be 1. Okay, so that's a limit that exists. All right, how about a limit from the left side? Well, let's go ahead. Let's do this one here. So the limit, lim, of f of x as x approaches negative 1. Well, I want it from the left, so I'm going to add a little superscript negative there. Okay, and this is equal to 0. All right, how about from the right? It would be too easy to pick the same point. I'm going to go ahead and let's do up here at 2. Okay, so the limit as x approaches, let's say 2, of f of x. I flipped that order. Not like it, I mean, you can do it both ways, but I think it's a good idea when you're thinking notation. You don't want a naked limit. You don't want to leave out information on your limit. So the limit of f of x as x approaches 2, and we want from the right. So I'm going to add in a little plus right there. Okay, it is equal to 4. It is equal to 4. All right, and lastly, a limit that does not exist. A limit that does not exist, okay? Let's go ahead and let's just do 2. The limit of f of x as x approaches 2 does not exist. Does not exist. Okay. Another one that does not exist as well would be right here at 5. This limit does not exist. And that is because the left and the right side will never, ever, 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 ever meet. You just have function values that are going straight up. This is another type of discontinuity that we will talk about, or we have kind of talked about. It's a vertical asymptote. And so we would also say the limit as x approaches 5 does not exist. Okay. Example number 4, and here's kind of the do you understand? This is an actual AP question. So the graph of y equals f of x is shown above. What is the limit of f of x as x is approaching 1? A, B, C, or D? I will give you a second. Okay, and hopefully you said that the limit does not exist. So as I approach 1 from the left, it's 3, and I approach 1 from the right, it is a positive 1. It does not exist. Congratulations! You've just answered your first AP problem. Okay, 1 point a day. That is all we want. All right, that is it. Hopefully we have answered the questions that we set out in the beginning. Do you know what a limit is? Do you know how a limit is similar or different than a point on the graph? Do you know how to write limit statements? And do you know how to read them? Hopefully you answered yes to all of those above. If not, we can talk about it more in class, or you can leave a comment, and I will do my best to go ahead and answer any of your questions. Here's some practice. Go ahead, pause the video, and you can give these a go. All right, here is the translation for number 1. The limit of g of x as x approaches -3, it is 6. Okay, so that's how you translate it into words. All right, here is example number 2. Go ahead, pause the video, and then I will show the responses to these. Okay, here are the solutions. On number 2, A, the limit of f of x as x approaches 2 is 0. B, the limit of f of x as x approaches 0 from the left is 2. The limit, or sorry, C, f of 0, what's the function value at 0? Well, the closed dot, again, is right here, so that's going to be 1. The limit of f of x as x approaches 0, well, the left and the right, they don't meet. Left does not equal the right, D and E. So you can put left does not equal the right. E, f of 2. Well, the function value at 2 is -1. And the trickiest of all these, f, the limit of f of x as x approaches 1, it is 1/2. And maybe you're like, how the heck did you get that? Maybe you guessed it right. There is actually a definitive process in order to go ahead and understand this. If you look at the slope between 0 and 2. Well, your slope here, right, this is a straight constant line, so slope is constant. Well, what's your rise? Your rise is -1, and your run is 2. So you're dropping 1/2, right? -1/2, that's your slope. So as you move from 1 and you move over 1 unit, you're going to drop 1/2. So that's how you know it's a positive 1/2. All right, store that for later. We're going to definitely use that more this year. All right, go ahead, pause the video. Here's number 3. Describe the difference between the following 2 statements. Okay, here you go. The difference between the 2 statements. Well, statement 1, obviously it's a limit, okay? And the c value, that's going to be what the function is approaching from the left and from the right as x approaches a. While statement 2, the c value is just the function value of h of x when you plug in a, okay? And a value or an example of this about how this could be different is going on right here at x equals 2. So for this graph, right, the limit as x approaches 2 from the left and the right, it is 0. Whereas if I plugged in 2 into the function, the answer would be -1, right? So those are different. That goes back to one of our key questions. How is a limit different than a point, or similar? You know, it could be the same thing, right? Like 4, the limit and the point are exactly the same. 8, the limit and the point are the same thing. 5, the limit and the point are the same thing. 7, okay, there's like literally infinite examples. Some no-goes, right, would be like 6. Okay. I mean, obviously 2, we talked about 2, and then, of course, we don't even have a limit that exists for 0, okay? All right, and then last but not least, number 4. Go ahead, sketch the graph with the following properties. Ooh, this is going to be fun. See what you got. Pause the video and... All right, here is what I got for this answer for number 4. This one was fun. Looking at the first condition, the limit as x approaches 1 of the function f of x is equal to 4, so we want the limit to be equal to 4, and also f of 1 is undefined, so that's why I put a hole there. That's kind of what I did first. Maybe I should label this graph too. This is y is equal to f of x. And then the second one, the limit as x approaches -2 from the left, that is equal to 3. Okay, and the limit as x of f of x as x approaches -2 from the right is 1, but the function value is 0. All right, hope you enjoyed this video. Hope you learned what a limit is, how to read it, how to write it, and I'll catch you in the next video. Peace. Oh, also, like this video, subscribe. It really helps, really just my ego, and I like it. All right, catch you later. Peace.